Hello, everybody. I hope you had a wonderful weekend. Today we are going to talk about the 10% rule. The 10% rule explains how much energy from the sun is actually passed on to each organism in the food chain. And it also helps us to explain why food chains can't get super long and why, when you look outside, you see mostly producers. You might see some herbivores, but it's not likely you're going to see a lot of carnivorous animals. We're going to explain that today. So before we get into the 10% rule, we need to talk a little bit about energy. Energy is not recycled. We can't reuse any energy that we have in our bodies. Once it's used, it's gone. We need a constant supply of energy from our food, and our food needs a constant supply of energy from the sun. Once we use up energy for just living our lives and moving around, most of it gets converted to heat energy. And our bodies are not very good at trapping heat. So the heat escapes our bodies and goes into the environment and then eventually leave the planet and go to outer space. And once the heat is gone, it's gone. We can't do anything with it. So we need a constant supply of energy. Our photosynthetic organisms, like plant and algae, are producers. They will absorb energy from the sun and will take that energy and use it to make food. Food for themselves and ultimately food for animals that might want to eat that plant. But the plants and the algae are producers. They're going to use up most of that energy for their own purposes, just to keep them alive, to allow them to grow and maintain homeostasis and produce seeds and fruits that they need to reproduce. And as they use that energy to keep them alive, it gets converted to heat and escapes into the environment. In fact, 90% of the energy is used up and lost as heat. So if we look at our energy pyramid here, producers make as much energy as they can, and they have 100% of the energy. It's 100% of the energy that's going to supply the entire ecosystem. But the producers use most of that energy for their own work, so 90% of it escapes. That means that only 10% of the energy that was in the producers is what actually gets passed on to primary consumers. And this is why it's called the 10% rule, because only 10% of energy is passed on from one trophic level to the next. So those primary consumers get only 10% of the energy that was in the producers originally. But then those primary consumers are going to use up most of that energy just to keep them alive and to help them reproduce. And so 90% of the remaining 10% escapes. And so 90% of 10% is 9% escapes and gets lost as heat to the environment, leaving only 1% remaining to the secondary consumers. And then the secondary consumers use up most of that energy. So 90% of that remaining 1%, or 0.9%, gets lost as heat to the environment, leaving only 0.1%. A tenth of a percent left for tertiary consumers. And then again, those tertiary consumers will use up most of that energy and it'll be lost as heat. So 90% 0.1% is 0.09%, leaving 0.01%, 0.01% to our top predators. This is one of the arguments for a vegetarian diet. It's that a vegetarian diet is much more energy efficient than a non-vegetarian diet. So energy efficiency, like your energy efficient home, you try to minimize the amount of heat you lose in the winter by insulating your windows and your doors, making sure that your house is nice and sealed so heat doesn't escape out of your house and let the cold air in. That's not very energy efficient. But if you insulate it and keep the energy inside, you don't lose it to the environment in the wintertime, you are more energy efficient. The argument for a vegetarian diet is that by eating only producers, you lose 90% of the sun's energy. But if you eat an herbivore or anything above a producer, you lose much more energy. So it's not as energy efficient. A lot of that energy is wasted. The 10% rule also explains why food chains can't get overly long. It's because top predators, they only have a fraction of the energy that's left available to them. And so if you were to take this, quaternary consumer up here and, that loses 90% of its energy to the environment, that would leave 0.001%, 1,000th of a percent of the total energy that we started with in the ecosystem. So there's just not a whole lot of energy left. So it's just harder to keep adding onto a food chain if you end up with less and less energy each step of the way. This is also why we see a whole lot more producers outside and more herbivores than we do carnivores. Biomass is the total mass of living tissue at each trophic level. And as you can see, much like the energy pyramid, this also decreases so that each level is only 10% of the previous level. So 100 kilograms is 10% of 1,000, 10 kilograms is 10% of 100, and 1 kilogram is 10% of 10. So it follows the exact same pattern. This is because of that energy loss. If you only have 10% of the energy available at a trophic level, then you can only support 10% of the living tissue. So for example, if I have 1,000 kilograms of producer here, and they have 100% of the energy. If the herbivores or the primary consumers only get 10% of the energy, then I can only support 10% of the biomass. So I get only 100 kilograms. So what you are going to be doing today is you're going to be doing a few activities about the 10% rule. The first is this energy and biomass pyramid handout. You have an image here, and you're going to first label the diagram with the different trophic levels. So producer, primary consumer, secondary consumer, etc. in the text boxes. And to label them, what you're going to do is you're going to double click on the image, and then you're going to type your answer in the text box. And once you have all your answers typed in, click Save and Close. And then there are a few questions about the energy flow pyramid and then also the biomass pyramid. So that's the first thing you're going to do, is answer these questions in the handout. The next thing you are going to do is complete this last slide of your virtual food web. And that's going to be putting in some arrows to represent energy. And so at this point, you should already have your food web completed might look something like this, and you should have taken one food chain out of that food web. So this is just an example food chain that you could have found in that food web. So what you're going to do is, just like last time, you're going to copy and paste these arrows as many times as you need into the food chain. So we're going to start with the little arrow, because this will show how energy is transferred in between the organisms. And I'm going to go back to my food chain slide and paste that. You're going to paste that in between each organism. Okay. Next you have the heat arrow. You're going to copy and paste that. And you're going to move the arrow to show the heat leaving the organism. And my heat arrow is much bigger than this arrow because remember, 90% of the energy is lost as heat. Finally, you need to copy and paste this text box, and you're going to type the percentage of energy that is lost to the environment or passed to the next trophic level. So you have to label each red arrow with a text box that shows how much energy. I'm going to position it over my arrow so I can label it. And here would be 90% energy lost as heat. And then here in between would be 10% energy lost as heat. And I just want to clarify that this should be of the total energy from the sun, from the start of this. So I don't want you to just like say 90-10, 90-10. Think, what is 90% of the 10% that was left? Well, 90% of 10 is 9. Okay. And 10% of 10 would be 1%. Once you are all done with this slide, you do just click the Turn In button in Google Classroom. You do not have to upload it. I have them already in my drive, so I can see all the work that you have done on these, and I can see how you have progressed on these. So you do not actually need to upload it into your Google Drive. Just click Turn In, and you will be all set. If you have any questions, send me an email.